All right, this is the Chapter 3 review. Remember, if you make corrections on your worksheet that you guys completed for the following problems, you will get full credit for the assignment, and also answer all of the Edpuzzle questions in order to complete the assignment as well. This is supposed to be in preparation for your test coming up tomorrow. So, let's dive right in and get started. All right, first off, linear systems. So, with linear systems, we have two different equations and we are trying to find what the particular solution is to each equation, okay? So first off, we have a set of ordered pairs for each of these sets of equations. What we're trying to do is we're trying to figure out what the solutions are for the following equations. So we are going to start off with the first one. So remember, ordered pairs are set up where you have x here and y here. X is our first order pair, y is our second order pair. So we are going to plug these values in to our equations, and we are going to figure out if these systems are solutions, if this ordered pair is a solution for the system, okay? So let's plug in 2 equals -3 times 5 plus 17. All right, so that's our first one. And that will end up being true because -3 times 5 is 15. Adding 17 to that gives us 2. So that's true. X plus y, does 5 plus 2 equal 7? We're plugging in 5 for x, 2 for y. 5 plus 2 does equal 7. So this is also true, which means this is a true statement. It is only a true statement if both equations are satisfied by the given ordered pair, okay? So 5, 2 is a solution. Now, let's see if 3, 7 is the solution to this one. So, remember, we're plugging in x, y. So, 7, let's do our first equation first. Plugging in 7 for y. -2 times 3 plus 13. All right, so -2 plus 3 is -6. Adding 13 to that does indeed give us 7. So, 7 is also true, okay? The first equation is true. Second equation, is that true? Let's do 7 times 3. Plugging in, -4 times 7 equals -5. All right, so 21 minus 28, that gives us -7. So obviously not true, okay? So not a true statement. So that means if one statement's not true, but one is, that means the entire system isn't true. If both systems aren't true, that is also the case. All right. This one, once you go through all the different situations, you find out that once you plug it in, it will not be true, okay? You'll not get a correct solution for this one because the second equation will end up not being true. All right, so that is how you solve in your system. Same rules for equalities and inequalities. Just plug in and determine if it's true. All right, solving system graphically. Let's go through this real quick. So, how you solve system graphically is you have to change your equations to slope-intercept form and then graph them and find where the solutions intersect, okay? So I'm going to do this one real quick. Let's actually do them all at once. So y equals -2x plus 14. And then also y equals x plus 5. How did I get that? I brought x over to the other side, makes it a negative, multiplied by -1, and everything turned positive as a result. All right? So y equals x plus 5. All right, this one, I can do the same thing. This will turn out to be bringing 3x to the other side, multiplying by -1. Y is less than or equal to 3x plus 4. Why did the sign flip? Because remember, if you multiply or divide by a negative, it flips, all right? This one, you get y is greater than 2x minus 1. -2x, my mistake, all right? For this one, you have it already in slope-intercept form, so you don't have to worry about it. Now, I could take the time and graph this for you, but for the sake of time, I am going to use a already pre-made graph. So let's do that real quick. All right, pre-made graph. This is what we got. All right, so this is the first problem. 2x plus y equals 14. X minus y equals -5. It is not in slope-intercept form, but if you did graph it correctly in slope-intercept form, let me change this one, for example, over. Y equals x plus 5. Same graph, right? Same graph. X minus y equals -5. It's the exact same thing, all right? So you still have your two lines. So the intersection is the solution to the problem. So 3, 8 is the solution to number 5. So number 5 is the solution. 3, 8 is the solution to number 5. Next up, we'll do our second one. Now, this is the one where you have inequalities. So remember, with inequalities, the area where the shaded region intersects is where your solution is going to be, okay? So for number 7, it's this region here, all right? The right-sided region. This is what your graph should end up looking like, all right? Okay, last one. Last one's an absolute value equation. Remember, how you graph an absolute value is it's always going to end up being a V, just like this, where it's going up 1 over 1 each time. And then you figure out where your y-intercept is. If I were to change it, this, x plus 3. Remember, if it's plus 3, it goes to the left. It goes in the opposite direction that you would expect. Goes in the opposite direction you would expect. All right, so let's pull out these graphs here. Your solution for this one should look something like this, okay? This region here is your solution because this is where it intersects. You do not have to shade these parts with different colors on the test. Don't worry about that. Just show me where the region of the solution is, all right? That's how you graph that, okay? All right, so that gives you an idea of how to graph these different equations and inequalities. All right, classifying as independent, consistent, dependent, consistent, and inconsistent. All right, so this gets a little bit more involved because you have to figure out if they are either the same line or if they are a different line. So let's do that real quick. So let me find my little marker here. There it is. All right, so let's go y equals -x plus 6, taking x over to the other side. And then also, let's change this one, -y equals -x plus 4. Got to multiply by 1 because y is still negative. Y equals x plus 4. Now, it's a different line. They're not parallel when there's a different slope, okay? So since there's a different slope, we can classify this as independent consistent. Independent consistent solutions only have one solution, okay? So if you see a line that just has one solution, a system of equations that has just one solution, independent consistent. All right, this one here, I believe, is going to turn out to be parallel lines. I'll graph it real quick for you. All right, let me undo that real quick. Get my eraser out. All right, easy peasy. All right, so -x plus 6, y equals -x plus 4. Same slope, different y-intercept. When you have that, that means you have parallel lines. Parallel lines do not have a solution, which means it's inconsistent. All right, so let's figure out what these are. Y equals -x plus 4. Then also, this one will end up also being y equals -x plus 4 when you go to solve it. Because take 2x over the other side, it becomes a negative. Divide everything by 2. Same equation ends up having all of the same solutions. So the solution to this one is the line itself. This is your solution to this system of equations, the line itself. And it's classified as dependent consistent. Solving by substitution. All right, so when you solve these, you have to solve them by solving for one variable for one of the equations and then plugging it into the other ones. So this one's already set up for us in that y is already available. So we're going to plug in y to our second equation. You cannot plug in to the same equation when you solve for a given variable. That is not going to work. So 2x plus 5 times the quantity, 3x plus 9 equals 28. All right? So that means 2x plus 15x plus 45, getting through this, equals 28. Which means 17x equals 28 minus 45. I actually am surprised I'm getting a calculator out for that. 28 minus 45 equals negative 17. So, once we know that, x equals negative 1. Once you do that, okay? Once you do that, you plug it back into the first equation. It actually doesn't matter if you plug it into the first or second equation once you have just one number. So, let's do that. We're going to plug it back into the first equation. Y equals 3 times negative 1 plus 9. Y equals negative 3 plus 9 gives me 6. So your correct answer as an ordered pair would be negative 1, 6. Make sure you write it in ordered pairs in the test. All right, the next one, I'm just going to give the answer real quick. The correct answer to this one is, let me find my marker again, 15 over 2 and 3 over 2. If you happen to have made a little bit of a mistake, make sure to check back on your work. If you don't know what you did wrong, ask me. Solving by elimination. Okay, so for this one, rather than solving for a given variable, you are actually cutting out one of the variables in the equation. So let's do that You're actually figuring out how to cut out one of the equations, one of the variables within both equations. So how you do that, eliminating a variable, you figure out how you want to manipulate the equation to cut out a variable. So best way to do it for this first one here is I think I'm going to multiply the first equation by negative 1. All right, if I multiply the first equation by negative 1, that means I'm distributing negative 1 into all the terms, okay? So, negative 3x plus 2y equals negative 7, okay? So, now that we have these two equations, we just manipulated this one, so now we just have negative 3x plus 2y equals negative 7. I can take out these variables because they are opposites, negative 3 and 3. All right, so 7y equals negative 14. Okay? All right, so y, dividing both sides by 7, y equals negative 2. Once I have that, I can plug it back into one of my equations, and I'm actually going to plug it into my first one that was not manipulated. So 3x minus 2 times negative 2 equals 7. So that means positive 4, so subtract 4 from both sides. 3x equals 7 minus 4 gives me 3. X equals 1. So my correct answer is 1, negative 2. Okay? 1, negative 2. All right. The second one, if you were to go through the whole process of solving it, the correct answer would be 5, 2. 5, 2. Make sure to detect where your mistake was before and make the corrections before you write down the solution. But what I would do first is I would immediately eliminate the 2, 7y since they're already opposites and then solve from there. All right, story problems. This is what everyone is having a bit of a difficulty with. So story problems. Find two numbers whose sum is 3,147 and whose difference is 135. So remember, we are breaking this down into two separate things. So two numbers, my dog is barking, two numbers whose sum is 137, and then two numbers whose difference is 135. So two numbers whose sum is 137, that means I'm going to let x equal my first number, y equal my second number, okay? X equal first, y equal second. Because we're working with systems of equations. So, two numbers whose sum is 1037, that means x plus y equals 3147, and whose difference, which means x minus y, is 135. All right, I think the best way that you would solve this is eliminating the y's and then solving from there, but the correct answer to this story problem, there's two answers, 1,641 and 1,506. Okay? That's how you do it. It's all about translating what it is, and then you guys will know what to do from there by solving by substitution or elimination. Sometimes you can make some simple mistakes in there. All right. I'm going to shut my door real quick so my dog stops barking. All right, next one. Jay took 10 hours to travel a total of 1,100 miles. He averaged 50 miles per hour in his car and 200 miles per hour in a small plane. How much time did he spend in each? All right, so this one is rather unique. This is not one that you are used to seeing, so we are going to go through it real quick. All right, so we're dealing with, we have 10 hours, 1,100 miles, and 50 miles an hour. So we know the distance, rate, and the rate, okay? We know the distance of 1,100 miles. We know the rate of 50 miles an hour and 200 miles an hour. What we don't know is the time. The time is what we're trying to figure out. So let's make our little chart, a little fancy schmancy chart here. Mine's not very fancy, but it's okay. Distance equals rate times time, okay? So distance. We know that our distance, we know that our rate, first of all, we're going to do the car for the top and the plane for the bottom. Car is 50 miles an hour. The time is what we don't know, so that's x. X is going to be the car speed. And then 200 miles for the plane. We're going to make y the plane speed, okay? So, remember, distance equals rate times time, okay? So, the car speed is going to be 50 times x. Plane speed is going to be 200, or distance is going to be 200 times y. Okay? So, we are trying to find how the car and the plane put it together made a total of 1,100 miles. So our first equation will be 50x plus 200y equals 1,100. 1,100, okay? That's our first equation. Our second one is, what is the total time between the car and the plane? X plus y equals 10. The sum of the two times makes 10 hours. Sum of the times between the car and the plane, 10 hours. All right? So, once you get to solving that, you will determine that the car time, the time he was in the car, was 6 hours. And the time he was in the plane was 4 hours. This is how you set it up. Okay? Make your corrections from there, and your answer will be 6 hours and 4 hours. Okay? If it takes 5 hours for a plane to travel 1,400 miles with the wind and 7 hours to make the return trip against the wind, find the wind speed and the plane's airspeed. All right, so this one is also similarly a little bit involved. So, here we have, what do we know? That's what we're trying to figure out. We're trying to know, we do know the number of hours that the plane took with the wind and against the wind, and we know the distance, okay? We're trying to find is the speed, the plane's speed, okay? All right, so the trip there All right, we're trying to find the plane's airspeed and the wind's airspeed. So we're going to let P equal plane speed, plane. We're going to let W equal wind speed. Okay, so plane. First off, we're dealing with another distance equals rate times time problem. So chart, bada bing, bada boom. Distance, rate, time. All right, so we know that our time is, we're going to make the top, we're going to make the top one with the wind and the bottom one against the wind. Okay? Against the wind. So with the wind, we know that our rate is the plane speed plus the wind speed, because if we're traveling with the wind, it adds to our rate of speed, okay? So on the flip side, being against the wind, it'll be the plane speed minus the wind speed, all right? So time. So the time is 5 going with the wind, and going against the wind is 7, all right? And then we know our distance for both is 1,400. All right, so how do we set up this equation? The way that we set up this equation is we make two equations for with the wind and against the wind, okay? Because remember, rate times time equals distance. So our first equation is with the wind. 5 times the quantity P plus W equals 1,400. Second one, going against the wind, it takes 7 hours. Distance equals rate times time. 7 times the quantity P minus W equals 1,400 again. Because remember, oops, made a little error there. So it's 1,400 against the wind. All right? So from here, you end up distributing the 5 and the 7 into each equation, and then the best way to solve this would be via elimination, all right? Once you solve by elimination. Because you can divide both sides by 5 to make this, and divide both sides by 7 for your two equations to make this easier for you. If I divide both sides by 5 here, I get P plus W equals 280. Similarly, if I divide both sides by 7 on the bottom equation, I get P minus W equals 200. Okay? So, once you solve by elimination, you can determine that the plane speed is 240 miles an hour. Plane speed is 240, and the wind speed is 40 miles an hour. So, that's how you set this up. Quite a bit of determination in how you set it up, but that is how you are supposed to do it. All right, this is something we've never done before. I'm actually going to do this one with you guys in class before you guys start. So we are going to skip this one for the time being. Writing systems of inequalities. Okay, so we kind of talked about how you're supposed to do this in class yesterday, but let's go through it real quick. So first off, you got to figure out what your lines are. Remember, if your shaded region is above the line, it means it is greater than, I believe. I'm fairly certain that is correct. Yes, it is. So here are your two lines. So once you take a look, first off, figure out your y-intercept, plus 1. Okay? And then what's my slope? I'm going down 1 over 2, which means my slope, starting here, down 1 over 2, means my slope is negative 1 over 2x. Then remember, shaded regions above, y is greater than. All right? Bottom one. Going down, Shaded region is going down, so we're going to have a less than. The line is solid line, so it's also going to be equal to, okay? Y is less than or equal to, what's my y-intercept? -2. My slope is up 2 over 3. Up 2 over 3 means I have 2/3 x. Okay? That is writing a system of inequalities. Kind of eyeballing it from the graph and then making your determination, okay? All right, writing systems of inequalities, but it involves an absolute value. Okay, remember absolute value? So if it's above the absolute value, it means we have a greater than or equal to, okay? So, and remember it's a dotted line, so we actually don't have the equal to in here. We don't have the equal to. Okay, so y is greater than absolute value of x. Is it moving from left to right? No, then we can close off our absolute value symbol. Minus, because it's going below the x-axis, 3. Okay? Because this is where our vertex is. It's all about where the vertex is at. All right, our next line. What is our next line? Well, it's actually y is less than or equal to 2. Okay? Because it's less than, going down, and the solid line indicates that it is less than or equal to. It's equal to. All right, last thing, minimizing and maximizing. So minimize and maximize the objective function z equals x plus 5y with following constraints. All right, I actually have this one done on a graph, okay? So we are going to take a look at that. Let me pull it up. We're actually going to put it on the side here. All right, so your lines, I graphed the constraints already for you. So x is greater than 0, y is greater than 0. Let's go through it step by step. So if x is greater than 0, that means it is going to be on the right side of the x-axis. If y is greater than 0, it's going to be on the upper half of the y-axis, which means the quadrant is going to be in as quadrant 1. So I'm going to pull it up here to make it easier for us. Graphing this, remember when you graph this on paper, you're going to have to change these to slope-intercept form. I made it easy in that I just put it in the calculator, but this gives us where the actual solution will end up being. So our solution is coming out to be in this little triangle here, okay? We'll zoom in on it. X plus y is less than or equal to 4. Let's put that on there. So where we have a common solution, shaded region, that is what we are going to use, okay? So let's use this graph, since we have all 4 lines graphed here. Let's figure out what our vertexes are, okay? Because remember, when we're minimizing and maximizing, we need to use the vertexes on the edges of our solution area. So let's do that real quick. My first vertex I'm going to use is 0, 2. Okay, let's pull that back up. 0, 2. So I got that one marked, okay? 0, 0 is my next one. I just use the vertices on the edge of my solution area, okay? My third one, 4, 0. And my last one is 3, 1. All right, so when I have the vertexes, here's what I do with the vertexes of the graph that I have, okay? So I have my 4 vertexes. Now I use these vertices to make a t-chart, okay? So my vertex x, y, and I plug it in to my objective function, okay? This is where the objective function comes in. And then I can find my values, okay? My z values. So plugging 0, 2 in, I'm just going to bring this down to make it a little bit easier. I get 0 plus 5 times 2 gives me 10. Because this is my y value, I'm plugging it into my objective function. 0 plus 10 gives me 10. 0 plus 0, well, that gives me 0. 4 plus 5 times 0 gives me 4. 3 times 5 plus 1, or 3 plus 5 times 1 gives me 8. So my minimum value is the lowest value from that calculation. So that's my minimum value. My maximum value is 10. Okay, that's how you find minimums and maximums. You graph your constraints, find the common region, or the feasible region is what the term is, feasible region, by graphing these lines. Then find the vertices on the edge of your region, which is these 4 spots here, and then use those ordered pairs to graph your function. All right. All right. I know that was kind of like drinking out of a fire hose. If you need some help, you can slow down the video, make it sound like this, and then or if you have questions, you can always ask me later on by sending an email or some other way of contact. All right. So hopefully this video was somewhat helpful in getting the solutions down. Make sure you make those corrections on your paper before you turn it in. And I will see you guys tomorrow for your test.